Starting recording. Welcome back to my YouTube channel, guys, and today I'm gonna be teaching you guys how to do algorithms. Today I'm gonna be discussing our constructor. The constructor is a pretty simple algorithm you can make in the O(n) of times. So n stands for here is the number of hashtags there are. So what you're going to do is basically just open the file. Loop through the file. And then we're going to be grabbing just the element, the what is it called, the hashtag or the string from the file. This one's very simple. What I recommend you guys do is look at the f string. F stream library. Main reason is because it's a fairly simple program. If you actually need help implementing it, just give me a message. I'll give you some documentation of it. I also posted documentation on the Discord server, just in case you're still stuck. So then we open the file, we loop through the file, and then we grab the string.
We also have to make into an entry, right?
Yep. So you can do this in different ways. Entry. Create entry. I'm going to make that purple. So when you create an entry, you have to assign it as a... You can just create it, like entry. Entry T, and then you can do t.pop, and then t.string to manipulate it. You can also do some other variations that you want. You just need to look at documentations and how is it called? Some example codes if you actually.
How come we didn't have to put anything for the first TT1?
Main reason is because Dr. Schroeder already has it implemented where you're grabbing, the files. If I remember correctly, I think I stole some of his ideas when creating TT2, because he also does file manipulations on the main. If you guys don't remember, let me see if I can find it. So maybe I'm wrong, but I think it's here. Yeah, he does this, Dr. Schroeder. You can do that as well and get the string. But I do mine differently. I'm not going to tell you why. How. Next is... this one's fairly simple. There's not much algorithms being applied here. So let me go to trend tracker. Just the strings. I hope Dr. Schroeder isn't watching these videos, by the way, and be like, huh, this TA? Yeah, let's fire him. Alright. Next is... Where is it? Next is size. This one's fairly simple as well, just... This
Everything
one,
is awesome.
yeah, runs in O of 1. And you just return your e.size. Or if you have a counter, you can also do that. Fairly simple, this one. Alright, so let me explain the easy ones first, and then we'll get into the more difficult ones. Or the ones that actually need the logic behind it. So you have this thing called search. Do you guys know what that is used for in this case?
No.
For tweeted and popularity.
Kind of, but search is a helper function that you're going to be implementing. But what implementation are you going to do?
Binary search.
Yep.
Binary search.
Yeah, so it's going to be a binary search implementation. Where, what happened if you don't find the item?
-1.
Yeah, you return a negative index. And this can be used as a Boolean statement. So, for example, let's say I searched this item, this string. Oh, it's not there. It returned a -1, so I guess I don't go inside my if statement where I manipulate it. That's an example of how to use this. There's a lot of documentations how to implement binary search, so I don't really need to teach that. And also, I believe Dr. Schweller also teaches you that. Now, let's get into the fun part. Where you have E vector and S vector. So you have this vector called S. Has he already discussed this about you guys? And you have the...
Not really.
Alright. So you have these two vectors. And the instructions say that you have to have a maximum of 3 items in your S vector. And you can have like as many items in your E. So let's say like this, a bundles of items. So it's going to be keeping track of your top 3. How it does that is by doing an insertion sort. So whenever you tweet something, this, let's say this is going to increment. You have to compare it each time to your S vector. Whatever indexes it has. Main reason is because let's say this new item is 9 and this item is 10. Let's say I call this new item, let's say I tweet it 2 times, so it goes to 11. I have to compare it. So this new item, let's call it new. This new item needs to check each case. Like, hey, am I bigger than this guy? Oh, yeah, yes I am. I switch. And let's say I have an item that it's around 40 tweets. And my highest one here is, I don't know, 50, no, 39. So, what I would do is just like, check each item. Like, let's say this is 30, 37, 38. So this new item, I compare like, is this item bigger than this one? Yes. I go to the next one. Is this item bigger than this one? Yes. This item bigger? Yep, it is. So I just start swapping from here. From here, I swap 40, 39, and then 37. I mean 38, 38. So I'm gonna be swapping. Or, I mean, what you can do is, there's going to be, let's say this can be 40, you can do this, swap these guys, this turns into a 37, this turns into a 40, swap these guys, this turns into a 38, this one turns into a 40, and then I swap these guys, this one turns into a 40, this one turns into a 39, and similar to how you did top K trends, you're just going to push back the last element. So right now my order is 40, 39, 38, 37. Just pop back that last element. So now you get the gist of how this algorithm's going to work, right?
Yeah.
Yeah.
That's so that little last example that you did, that's for the top K trends, top 3 trends.
This is for tweeted. Main reason is because I forgot to explain. S is gonna hold each and every single index. So for example, this is 39 pops. let's say it's a random index in E. So let's say it's right here. Let's say that's 1, 2, 3, 4. There's this index 4. Right here, there's 38. Let's say it's the beginning, so that's 0. 37. This is right here. That's let's say 10. And 40. This is like right here. And let's say 5, 6. 6 seems nice. So your E vector is not gonna be sorted. You're only gonna be keeping track of 3 elements. And within those elements, they're going to be in your S vector. So right here, it's going to be looking like, right now it's 5, 4, 0. So 5, 4, and then 0. This is going to be the order that you're going to be using it. And then, let me just, copy. Discussion on.
What is the runtime for insertion sort again?
Depends how you use it. Because if you're talking about insert sort in general, it's gonna be n squared. Most sorting algorithms are gonna be in n squared, such as bubble sort, select sort. This is just insertion sort. That's how many items you want to input, up to n variables. How you're going to be manipulating this is it tells you to have an insertion sort or like the runtime of, I believe, where's tweeted?
It's right under size on top of popularity.
Oh, this one runs in log of n. Oh god. What did I do here? Let me reread my code.
Wait, I thought tweeted was login.
Yeah, it's log of n. Yeah. So, yeah, my mistake. Okay, now I remember. Yeah. So insertion sort, I believe it. Let me Google this. Insertion sort runtime. I feel like it runs in n squared. Yeah, it runs in n squared, but how you're gonna be manipulating it is gonna be in constant. Keeping the log of n, the binary search that you're gonna be implementing, as the fastest, the longest runtime. So we gotta look where this string is at. So let me. You get the gist of what you're doing with the S vector, correct? You're only keeping track of 3 elements. Only keeping track of their indexes of these 3 elements. You're not going to be sorting the E vector. You're going to be sorting the S vector, but you're going to be using those indexes to be comparing the pops inside the E. So a similar setup would be, let's say I'm at E, and I want to go to my very first element, my highest, my top, my highest, no, let's say I want to go to the middle, my second highest. So I do S at 1. And that will give me my second element, my second highest. Alright. Let me delete this. Because that's... Alright. Let me copy. Yep.
Wasn't E already sorted alphabetically?
Well, it is sorted alphabetically. I haven't looked at the file. But you need to sort it based on the popularity or how many times it's being tweeted, which is what S is going to be doing for you.
And now we only just do the top 3.
Yes. Yes. So now I'm going to get into the discussion of top trends. So let me look at my code. Let me look at the... Where is it? So, okay, I've gone over the highlights of the sorting algorithm, like how you need to sort it. So, tweeted. It gives you a string, right? Right? Gives you a string, a hashtag of h2.
Yeah.
And we wanted to run in O log of n. every single time I see O log of n, I think of like it's binary search or something is being cut in half. So remember this, like, oh, it runs in log of n. Well, each time I'm iterating through it, something's getting cut in half. That's why merge sort runs in around that runtime. It runs around, I believe, n log n. Runtime. Yeah. No, it runs in log of n. Well, worst cases, probably n log n. Oh my god, I hope Dr. Scholler doesn't look at this. Alright, so the next thing is we're going to be using binary search to find where the string is located rather than having to iterate through our items. Because at what time does a iteration take? Yeah, and what does the binary search, how long does it run? What is binary search runtime?
Live in.
Yep. What is best case runtime for a binary search? I believe best case would be constant because it's the middle index. Yep. You guys agree with me? Cool. So you're going to be using binary search to look where your item is at, the index. What happened if they don't give you a hashtag that's inside your e vector? What do you do there?
You just return parentheses. Right? I could be wrong.
Yeah, you just return. You don't do anything. So let me write this down in red. Don't do anything. If item / hashtag not found. So you don't return anything if the item's not found. So hey, that's not a lot of work. You just have an if statement saying like, oh, is this item here? If not, you're good. Now, what happens if you do find it? You have to check if that item is inside your... How do I say this? Because what do I do here? Let's see here.
And then you increase the popularity by 1, right?
Yeah, you increase the popularity. You first increase. You increase the popularity. And then the fun thing about this one is, what are you going to do next? You increase the popularity. Now, remember what I told you when I was describing the S and E vector? What are you guys going to do next once you increase the popularity?
Should we check if it affects the S vector?
Yep. So, you're going to first check if you have that index inside your S vector. Or if you have that item inside your X vector. Because you don't want to have duplicates of items. You know how I believe previously students had pop like short popularity, the string popularity run 3 times. I saw some students have this. So what we want to do is, oh god, oh yeah, I'm just gonna over here, just decrease you, and then do this, and then do that. That should work, and then do this. Oh god, that was perfect. Man, I'm so good. Let me go right there. Yeah, that looks good. So you're gonna first check if you have it. check S vector if HT is there. If it is, well, look what location it's at. So let's say this new item, let's say this is index 6, and at index 6, the popularity is, I don't know, 10. So, and then this is going to be, what is it called? What am I going to, index 20. And then E at 20 is equal to 9. Dot pop. So, let's say I'm looking for this item. I'm just going to be saying like, oh, is this index here? Is this HT? So I'm going to be comparing it. So is it equal to my S at this point? Is this true? Dot hash, hashtag here. If you do find it, you're going to be manipulating inside the vector. So you're not going to do any pushback, fancy stuff. So let's say this got incremented 2 times. I don't have to do, what I did previously. I created another variable here, let's say 20. You don't do that. Main reason is because we don't want duplicates of items. So instead you manipulate within the insides of the vector. And let's say this turns into 11. You just do a simple swap, and that's it. Swap. I hope this is like pretty decent explanation of how this works. Are
we also going to be checking the E vector to see if any of them get upgraded to the S vector?
No, because what's this? What's this? Oh, did I not do this right? Yeah, I didn't. You're not gonna be checking E vector in any of these cases. Main reason is because the S vector is gonna be the sorted one. The E vector is just basically how do I say this? A map. Oh no, not a map, because a map is ordered. It's mostly like a list of items that you don't know where things are, unsorted lists, basically. While the S vector is going to be your sorted list of these 3 items only.
And they're never going to get replaced by any of the items from the E vector, right?
No, unless it has a greater popularity. It's only going to be replaced. And the main reason I say check if the string is there first is because you don't want to have duplicate items with the same maximum of like 11. For example, the reason why I said 11 has to be greater? Because if you have it as 10, it's still going to be there. So if you do 10 here, it's going to still be here. And let's say you don't check if this item's here. In some, depending on how you have your implementation, some cases are like 10. Let's say this is 9. Index 21. Let's say you're at index 20 and you don't check if these items are here. There's 10. This swaps and you do a pushback on 21. 21 pushback. And that deletes it, keeping 20 here and 10 here. So these are duplicates. You need to check for duplicates here. So let me go to part 2. So what happens if you don't find duplicates? No dupes. Inside a string S. What I mean by no dupes is like you found that the hashtag you're messing around with It's not inside the S vector. So we're gonna be manipulating it by doing this. So similar to how I explained to you guys on the S vector, I'm gonna do a pushback on my new element. So this new E, and I'm gonna start comparing them. Yeah, I'm gonna start comparing them. If none of these cases are match, like if pop is not greater than this one, you just return at that point. You don't need to check further on because, like, I mean, it's the smallest item here, so just do nothing. But if it's another case where it's the medium, you start swapping, as I previously mentioned, swapping until you hit this point. New element. And now it's sorted. These 3 elements are sorted. They're the top 3 elements. And now you remove the last one. You kind of get what I'm trying to say?
Yeah, kind of.
That kind of did not seem there.
Wait, so if new E is not greater than any of the top 3 elements in S, we pop it, right?
Yeah, because it's the smallest element. Do you want 4 in your S vector? No, you want a maximum of 3 elements in there in the S vector. So there's no point in having that element there. Only if it's greater than any of the top 3. Then you start swapping it around and you get the last element. That element is going to be the new lowest popularity and you pop it.
Oh, what was that dupe stuff you were talking about?
So basically what I was talking about the dupe stuff is, in some cases, depending on how you do your implementation, you can get duplicate items if you don't check your vectors correctly. So basically, if I have this item in my S vector and I bring in the same item to compare it, you're gonna have a bundle of a lot of duplicate items. So let's say I have this item that's 20. And I keep tweeting it. So let's say I first tweet it. Oh, well, 20 here. I tweet again. This turns into 21. This turns into a 20. I tweet it again. This turns into a 22. This turns into 21. And this turns into 22. And they're all index 6. They all belong to the 6. Do you think this is correct?
Nah, because that's the same item, right?
Yep. Every single time you tweet, you're going to be comparing items. So you need to always check if this item is inside your S vector. Unless you have some sort of condition, because I don't know what conditions you guys might think of. We just don't want duplicates in our S vector, because that will mess around with our algorithm a lot when trying to see what are our top 3.
You just compare like the strings or what?
Yeah, you can compare the strings. Yeah, so like if I don't know, E at the current whatever binary search you have, the hashtag is within any of the top 3 here, then you don't do a pushback. You just manipulate it at that S index. So you're gonna be manipulating this guy a lot, because this man is basically your key on sorting this whole thing. If it's not there, you add it to the list and start comparing it with other members of the list, and then you do a pop back to eliminate the least. for example, when I mean like no duplicates, it's basically this is in 6. I add the 20 here, so 20. Let's say I tweet again. Let me check. Let me start looping through my list. Okay, I found it here. Let's increment it. All right. Let's say I add I increment again. I loop through my list. I found it here. 22. In this case, you're not checking anything. You're not checking if you have duplicate items. Does that make sense?
Yeah.
All right. That sounded with confidence, so I hope so. Popularity, fairly simple algorithm you're going to be implementing. So popularity, you just apply binary search.
So just to be clear, all the stuff with S is done in tweeting, right?
Yes.
Okay, because I was pretty confused about that part.
Yeah, so when you're sorting, it's all going to be in tweeted because every single time you're going to be tweeting, something is changing. Something is always constantly changing. So you got to make sure, hey, did this new variable increase? Okay, we know that this variable increases its popularity, but is it greater than the current ones we have? So we start checking. Alright, does that make sense, Victor?
Yeah, that makes sense.
Alright. Popularity, very simple. If it has -1, just don't do anything. Or return, I believe it's a return empty string. No, just return J, which is -1. Just return your binary search if it's -1, or just return -1. If it's not, you return your popularity. Else, if binary search outputs this, return -1. Else, return the pop. I'm not gonna print these out for because it's like fairly simple. Now, top trends. Does anyone want to explain that one? I think anyone can get this one. You just return. Well, you gotta check if your E vector is empty. So check the. You can. Huh?
I think for top trend, you just return the first element of S.
Yes. So you're just gonna return this first element of S. Yeah. It's gonna be fairly simple to that, and that's it. Let's see. What happened if your E vector is empty? What do you do then? If there's no hashtags in your E vector, what would you return?
Nothing.
An empty string, yeah. So these are some cases. Remember, like, because he will test you on the testing lines. So you gotta make sure, like, am I writing this correctly for his needs? Now, top 3. That one's fairly simple. Top 3. What would you do in this case?
You just return the whole S vector. Right?
Yep. But now let me give you this case. What happened if you only have one item in your S vector?
Yep, that's what I'm stuck in right now. I'm doing it.
You have if statements, so that way, okay, like if S is 1 or 2 or whatever, right?
Yep. So if the S vector is a size of, let's say 0, they all have the same popularity. No one's greater than no one. So S is empty. empty, meaning it has 0 elements, so the size will be 0. So E, you can just put whatever is inside it, man. You can just put whatever. You can just put the first 3 items. You can put the last 3 items. You can put items from the middle. Does not matter. I think it does not matter.
Wait, if it's empty, we just stuff it with whatever 3 items we can find?
Yeah. Wait, I think. Right? Yep. Yeah. All you need to know is you have to return top 3 things, and you have these items that start at 0. So there's some items that are gonna be 0, 0, 0. At that point, you just return any of these items because it doesn't matter which one you're returning. They're all gonna be equal to each other. No one's gonna be greater. So now, let's say, for case here, hypothetically, I have 1 item. Let's say this is index 6, and that's called Schwally. Schweller. I think there is one called Schweller. I'm not very sure. Schweller. What would you do then?
I mean, if you're just filling it up with random items,
But you
it
have
has nothing.
you have this
you do
item.
the same.
Well, you have this item. What do you do then?
Fill the other 2 out with random ones.
Yep. So you first input into the, I believe it's a string vector. You first input the items you have in your S vector, and then if you like have space, like empty slots, you need 3. You put whatever item. Same thing with here. Let's do Tamai here. You're gonna fill the first 2 slots of your string vector, and then the last one with any variable from here. Now, if you have all of them filled up, you just return the S vector. You manipulate it in a way where T has these 3 vectors. Let's call this Allison. So you're gonna return these 3 vectors. My God, I'm making a lot of arrows here. But does that make sense? What you're gonna be implementing?
Yeah, the fact that you're throwing in random items, if they're not completely full, does that mean that like all the items on E are the same popularity?
Yes.
Okay. So the only items that increase in popularity are the ones in the S vector.
Yes.
Okay, that makes a lot of sense.
All right. Any questions? Any concerns?
You got it, dude.
Man, I'm a great TA. I hope Dr. Schweller does not watch this video that I'm about to publish. I hope this file does not corrupt either, and also I have to wait like an hour or so just to publish the video. So, are you guys having any difficulties right now with some things?
If we do run into errors, we just send you a DM or anything like that, or
I recommend you guys do it and tweet it in like Dr. Schweller's little channels here he has. Main reason is because you guys can help each other out, and I can lurk around seeing what errors you guys are having for like
you don't care if we maybe post something or some of our code, or how does that work then?
Just snippets, like for example, error code where you landed, the error code, and I mean, if it's code that's not working, you might post that, I guess. Because Dr. Domite doesn't like it when people share code. But if it's code that doesn't work and you want to see why it doesn't work, then you guys can help each other out with that. I can guide you guys like, oh, you have this return statement inside a for loop, which I've seen.
Trying to explain code through like just text kind of like sucks.
Yeah. Yeah, it does.
Okay, well that makes sense. Thank you so much.
Alright, I'm gonna stop recording. Thank you guys for watching this YouTube channel. Remember, you can always watch my next YouTube video. I have a JavaScript GUI beginner level video there. Alright.